Welcome to Physical Science in the AM. I'm your host, Joel Sindaka. We're going to do a quick review of types of chemical reactions because it's been 10 or 11 days. The first thing is we took a look at three types of reactions. Relatively, well, the more complex ones are coming up. But synthesis means two things coming together or more. Two or more things coming together form something probably more complex. Decomposing. You can tell something's a decomposition. You look on the left-hand side and you only have one thing. The only thing it can do is split apart, right? Whether it splits into its elements or splits into two other compounds, it splits apart in some way. It could split into three things, could split into two things, something like that. So that's decomposition. They're essentially the opposite of each other. If I give you something like this, you didn't know anything else about it. I said it's a decomposition reaction or whatever. Predict the products. And you had nothing else. You just split this up into its elements. This one here, I wouldn't expect you to predict that it's KCl or something. So if you didn't have this, you'd just say, well, it's KCl2 plus oxygen, and then, oh, well, that's O2. I'm going to make a circle because, anyways, we'll just break it up into its elements unless you're instructed differently. And combustion is actually a type of synthesis. Something combines with oxygen. And I noticed after the class that, 11 days ago, that synthesis is more because it's a better answer if you say combustion. I missed that on one. I'll show you where. Organic combustion, though, always have carbon dioxide and water. You don't even have to think about it. So if you have carbons and hydrogen, you're just going to have carbon dioxide and water. And then you balance it out. You take a look at that. With metals and so on, combustion, oxygen combines. Now, we looked at a few of these and classified. I gave you the word reactions. There's one thing for the first example. It had to be decomposition. Took a look at aluminum, sulfur, two things combining to form one thing, that's synthesis. Three. Two things combining form another single thing, that's synthesis. Notice that this one here is combining with oxygen. It's actually combustion as well. Synthesis is correct, but I would actually give myself a half mark. So I'm going to add this again. I'm going to behoove you to add this into combustion. Now, that's not one I would expect you to be able to predict products. But that is combustion, it's combining with oxygen. And lastly, decomposition. Okay. Now, pause for a second to update the attendance. Then we'll take a look at these reactions. They're pretty tricky. About the complete the following reactions and balance. Now, the first 5 that we went through 11 days ago, I gave you the full reaction in words. This one I give you the chemicals, but we have to be able to come up with products in this case. Once again, I'll just quickly pause and update attendance, and then, all right. Now, taking a look at the first one, I have little hints underneath each one. Now, I told you this is combustion. How would you know that right away? It's about oxygen, right? And it's C's and H's, so it's organic combustion. Remember, don't panic, it's organic. It's just carbon dioxide and water, right? In organic, in a grocery store means something entirely different than organic chemistry. Okay? Organic chemistry is just carbons and H's, hydrogens, okay? Those kind of things. Nothing to do with the way something's formed. Now, so we got to know them. Combustion. Remember, organic combustion always produces carbon dioxide and water. So we put this down. CO2, water. I'm leaving space because we need to balance this. That's the tricky. Now, I'll just run through each one of these a little bit. Synthesis. Look up each of the ions, these elements, and write out the product. So I'm leaving the balancing. Don't try it right now. It'll come up. So we have to go on to 7 here in synthesis. Sodium and chlorine come together. They're going to form one thing. But we have to know what the charge on a sodium is. So you look on your ion and have that ready. The ion sheet, periodic table of ions, that side, not the side with all the numbers. And you look up sodium, and you see that it's +1. So I'm going to do a little bit of scratch work on the side. And put it over here, Na+. Then I look at chlorine. Chlorine's in the 17th column. It's called a halide. And it's got a -1. So I look that up on my ion chart. You're going to have that ready. Pretty well most classes for the rest of the year. So this one's a simple one to combine, right? A positive one and a negative one come together. It's 1 to 1. Just NaCl. You're familiar with that. Then you just have to balance this. Now, looking at the 8th water, and I tell you decomposition is one thing that's always stuff we have so far. So water is decomposing into H's and O's, but we have to remember, there's 7 things that come as groups of 2. It's a metal, it's just a symbol. It's non-metals that you have to be careful of. Now, you remember how to know which ones come as a group of 2? There's 7 of them, yeah. So, definitely includes hydrogen and oxygen. So, we're going to just write down H2 plus O2. Leaving space because you got to balance it. And the last one, I'll leave that because it's combustion again, and it's with carbons and hydrogen. So CO2 and water, you're going to finish that. This is the overall reaction for respiration with burning glucose in your cell. So I guess I'll leave it right. This one is really easy to predict. It's hard to balance. I'm going to give you guys time to balance all of these. Okay, so what I did in blue is scratch work. It's actually not part of the 7th question. So, time for you guys to balance. 6 and 9 are tricky if you want to do 7 and 8 first. They're pretty quick. Okay, we're going to try these out. I pause the video. If you didn't do them, pause again and try it. Balance. I said I'd do these 4 with you, but I said that 7 and 8 are easy. Let's just take it. Right now, look at this. I got Cl2. I only have 1 Cl in the compound. I put it in green. You can't alter what that compound is. You can't put little numbers. You have to use bright numbers. So, we got to say there's 2 NaCl. That means there's 2 Nas and 2 Cls on the right-hand side. You got to skip back and forth, left and right. Save information. The Cl2 is taken care of. Good. 2 of those. But there's also 2 Nas. So we need a number for a single element. And only balance with right. Now the water, similar thing, you look left, right, and see what's good. H2 and H2 are one. No, those are good 2 H's. O, though, screwed up. On the right-hand side, you have O2. Water only comes as a package as H2O. You can't alter that, so you got to put a front number. Now, I've got enough oxygen on the left to match the right, but it's screwed up the hydrogen. So then we get to on the right. That means you've got 2 times H2, so 4. That matches that 4. All right, we got that. I'm going to go up to 6 and then do nothing. So I'm going to show you a question. Oh, well, yeah, we'll keep it science. Now, when I balance 6, this is one where I actually truly did erase and then try something and then double it up and try it again. Here's how I think it through. Everybody thinks differently. Some people can look at these and know the numbers right off the bat. I'm not quite there yet. Don't think I'll ever. C2H6. So I look, there's 2 C's. I need 2 C's, but I'm doing this in pencil. It'll disappear. And then 6. So I need 3 times H2. But when I do that, I've got an odd number of oxygens, because I would have had, I'd have 4 plus 3, 7. 2 times anything, it'll never equal 7. What that tells me is I need to double my numbers. Combustion ones, that's so often if you get into that where you've got an odd number of oxygen, double what you were starting. This is why I left these for last. They're tied. So instead of 2 for the carbons, I'm going to put 4, and I'm going to put 6 here. Now, I'll put what I was originally thinking here, 2 and 3, but I'm getting rid of those. I've erased them. Because those were an odd number. I could tell that the oxygens would work, so I've got to have an even number of oxygen. That's why I did this. So in red is what's important. Blue is what I've erased. Yeah. Then, let's see if this works. We can finish this up. First of all, I'll double check. The Lord love it does. 2 carbons, I've got 4 carbons. 6 times 2 H's, so 12 H's. I need 12 H's. If I doubled up those other things, I have to double up this. Okay? So take care of everything else and leave oxygen for last. Okay? Where do you have the sheet? Way before that. 11, 12, 8. Anyways, I'm going to just get rid of these scratch numbers here. Yeah. Sorry, just updated here. Okay. This seems to work now, but I need to do the oxygen. So I've got 4 times 2, that's 8. Taking 8. And then 6 times 1. That's 14. 6 and 6, right? I need to go 7 times 2. This balances. Science, kind of. Now, I will just pause, or is there one for you? Hang on, I'm going to pause and find the sheet. Okay, back to this. This one here, actually this one's easier to balance than the other, because I won't end up scratching up. So I'm thinking on the left, I've got C6, so I need 6 carbon. For 6 carbon dioxide, I need 6 carbon. Always leave the oxygen for last on combustion. And 12 hydrogens on the left, so I need 6 times 2 for the water. 6 times 2 H's. There we go. And if I look at this, I'm going to double check. 6 carbons, check. 6 carbons. 6 times 2 hydrogens, check. That works. Now, to add up the O's, it's a little tricky. I've got 6 here, 2 here. I've got 6 times 2, so 12, 18. I already have 6 as a group here. In my head, here's how I'm working it. I've taken care of 6 there. This might work. But all I need to do is now count out I need 12. I'm going to put a 6 in front of a single ox. It's just arithmetic, but it's a lot of back and forth. That balances. But it's not easy, so don't be frustrated. I expect you to take 3 or 4 minutes or something. Don't expect to just look at them. Like 7 and 8, I do expect you to do that in a minute. But 9 and 6, this should take you a few minutes. Okay. Any questions at this moment? It's the balancing that's tricky. I don't think saying is this combustion. I don't think that's it. Oh. Well, we'll get more practice with the balancing. First, we're going to take a look at single replacement. One more type of reaction. Okay. Single replacement reactions, one element replaced by another in a column. The general form, when a cation is positive is replaced, well, positive ions come at the start of column. So this, it's a metal basically. We assume a metal will form a cation. You see how A and B really switch places here? That's what's happening. A single thing comes in, pushes out the other. So here's an example. Iron and copper. They're both metals, they can replace each other. Pause. Copper and iron. They flip up. And when metals are in element form, when they're by themselves, they're single. Okay? You can't see with 2 behind it or Fe with 2 behind it. You're not modeling. Okay? When a negative, an anion, is replaced, the negatives are the second thing. So I put an X and a Y. That C is like a variable, it's not carbon. They switch places. Now the ions that we use, the anions that we use will be from the 17th column, stick to that, and they always come in solution 2, 1, 2. So for example, bromine, if it replaces iodine, that well, we scoop the iodine out, put the bromine in, you have to look up the charge level to see if they KBr or KBr2 or something like that. Anyways, good enough. Now, they don't all work. This is why I have this activity series. You better decide. Use this activity series to decide if a single replacement reaction will make any progress. Sometimes there's no reaction. A given element will only replace an ion in a compound if the ion is below the element in the series. Okay? Now that's needed. This activity series is needed if I don't give you the properties. I'm going to go back up and use this activity series to see, confirm, yes, this should. Look, iron and carbon. Let's take a look. I find iron on the list. Stop working on it. I don't know why. I'm going to pause it. Okay. We're loaded back up. If you've just joined us, you're tuning in to Chemistry in the AM, part of your physical science course. Okay. Anyways, we were going to compare boards. Why would iron replace carbon? Well, a given element only replaces if the ion is below the element. So the element is iron. We got iron. Copper is below it. It will replace it. You see that? That's why that one goes through. It's the other way around. This is water. Likewise, with the non-metals, bromine is higher up than iron. That's why it replaces it. If it's the other way around, it won't happen. Okay? We'll see. Now, those ones were complete. If a reaction is possible, complete the equation of balancing. Well, let's just take a look right off the bat. Is this bromine higher than chlorine? No. Bromine, chlorine is higher. So you're going to just put NR, no reaction. I'm fine with just NR. That's it. Nothing to balance. It won't happen. Magnesium and zinc. So I look up magnesium, I look up zinc. Is the single thing higher? Magnesium is higher than zinc. It will happen. It'll do some replacement. So I'm going to leave that now. I'm just looking for the ones that don't work, and then I'll figure it out. Cl2 and KBr. So chlorine is higher than bromine. This one's going to have Sn and so tin. And you wouldn't know that necessarily, but Sn isn't like Ti for tin, because that's something else. That's titanium. Tin, you can't use it. Sn is used. That's how I know. Is it higher up than sodium? Be willing. Where is sodium? It's on top. Nope, it's not going to happen, right? So I'm going to put in a no reaction. NR. That means we can complete the A. Now, you might have to do some scratch work because I don't think you have the ion chart memorized. You got your ion chart from me. You think if magnesium goes into a compound with chlorine, what's the charge going to be? So I'm going to say, well, and magnesium. I look it up. It's in the second column in your ion chart. It's an Mg with 2 pulse. This is scratch work in blue. The chlorine is a minus. Now I can form a compound. Well, first of all, I know zinc is going to be pushed up. So Zn plus MgCl2. That's the blue tone, right? 2 positive with a minus 1. Now, when I look at this, it's balanced. It's all 1. So you don't even have to write 1. If you want to write 1, 1, 1, 1, go ahead. 1 zinc, 1 zinc. 1 magnesium, 1 magnesium. 2 chlorines, 2 chlorines. The blue is scratch work. It's not actually part of the problem. Wouldn't have margin. Chlorine and bromine. So I know it's going to happen because we've done this. I'm going to just lay off on the side. Well, K plus. I looked that up on the chart. I know that the bromine is going to be alone, so maybe I'll write this. Then, chlorine, when it forms an ion, is Cl minus. Hey, this is easy. 1 to 1. So, KCl. Then I've got to see if it's balanced. Are you following? Nope. Okay. So, to balance this. Jesse, I'll wait for you guys. You tell me. Yep. 2 there. That takes care of the BRs. And that screws up the Ks, right? But this takes care of both the Ks and the Cls. That's kind of like 2 of everything. The balancing is from grade 10. And I know you guys need practice. Okay. Now, I'm going to pause. You guys practice. Okay. My board has stopped working, but I've handed out a reactions review. We're going to look at question 3. And that's what we're going to work on using the activity series right now. I'll post it on Google Classroom.